Welcome to The Explainer. Today, we are taking a massive conceptual leap, like really massive. What happens when we look far beyond our terrestrial borders to tackle the ultimate architectural challenge, building actual cities in space? We aren't just going to look at the cold, hard physics of surviving the vacuum. We're going to bridge that foundational engineering with the architectural aesthetics of human well-being. We're exploring how to build not just a survival bunker, but a true, resonant home among the stars.
Okay, let's dive into this with a quote that just perfectly sets the stage. Konstantin Tsiolkovsky, a true pioneer of astronautics, wrote, "Earth is the cradle of mankind, but one cannot stay in the cradle forever." It's a visionary hook, right? It reminds us why we're even having this conversation. Exploring and eventually settling beyond our planetary cradle is this inevitable pull on the human spirit. But to actually pull it off, we have to rethink absolutely everything we know about how we live.
So, to make sense of this huge topic, we're going to build this explainer like a hierarchy of needs. We'll start at the base with the Space Habitat Challenge and engineering O'Neill cylinders, the physical hardware required just to keep us alive. Then we'll move up the pyramid to the software of our future homes, looking at designing for well-being, the symbolic 369 aesthetic cosmology, and finally a blueprint for tomorrow.
All right, part one, the Space Habitat Challenge. Let's face the music here. The realities of space are uncompromisingly harsh, and you can't exactly pitch a tent in low Earth orbit.
The foundation of our space hierarchy is built on some totally strict constraints. Surviving up there means dealing with intense cosmic radiation, the debilitating effects of microgravity on the human body, and incredibly severe power budgets. For instance, recent research from the ASPLS Computing Conference analyzed self-sustaining habitats like the Kalpana 1 design. They found that because a habitat has to dedicate almost all of its harvested solar power to life support, the maximum power budget left for computation might be as little as 10 kilowatts. To put that in perspective, 10 kilowatts is barely enough to run 2 standard household ovens. Yet, it has to run the computing for a piece of a city. Current Earth-based models for a similar population would need over 200 kilowatts. So every single watt, every drop of water, and every breath of air has to be meticulously accounted for.
Let's move to part two, engineering O'Neill cylinders, and see how this builds into actual engineered solutions. This is the hardware of our off-world survival.
The most robust solution we have on the drawing board is the O'Neill cylinder. Physicist Gerard K. O'Neill first published this visionary blueprint way back in 1974, which sparked intense study and led to the famous NASA Stanford summer studies. But notice, this isn't just retro sci-fi. In 2019, Jeff Bezos explicitly linked his Blue Origin vision to O'Neill's colonies, and today we're seeing stepping stones like the Orbital Reef project taking shape. The concept has evolved, but the core engineering necessity remains exactly the same.
The physics of space dictate our architecture without compromise. We absolutely need between 0.9 and 1 g of artificial gravity generated by rotation to prevent severe bone and muscle loss. Microgravity is an absolute showstopper for long-term health. But to maintain human physiological comfort, basically to stop everyone from getting incredibly dizzy, that rotation has to be slow. We're talking under 1 revolution per minute. And to survive solar flares, we need roughly 10 tons of shielding per square meter, mined from the moon or asteroids.
10,000. What's really interesting about this number is that 10,000 was the target population capacity for the very first baseline settlement proposed in that 1977 NASA design study. Because you need a massive radius to spin slowly enough while still generating 1 g of artificial gravity, these structures simply cannot be small capsules. They have to be sprawling, floating cities.
But here is where we make our pivot to part 3, designing for well-being. We have to transition from the clinical hardware of survival to the warm software of human well-being. Because human beings cannot and will not just survive in a cold, sterile metal can. We need a home. This brings us to the principles of environmental design and what's known as biogeometry. When you're living inside a closed-loop machine, the physiological stress can be immense. Environmental design utilizes shape and proportion as spatial field modulators. Basically, it uses physical geometry to influence how energy and sound move through a space. The goal is to enhance harmonic resonance within these closed environments. It's about taking a rigid, engineered cylinder and bridging the gap so it feels like a living, resonant ecosystem, a psychologically comforting space that echoes the organic, fluid dynamics of Earth. And that profound desire for an organic, comforting environment leads us straight into part 4, the 369 aesthetic cosmology. This is the absolute apex of our hierarchy.
So the crucial point here is this. What we are exploring is strictly a visionary design language.
The Etherbios 369 Tesla matrix is a purely symbolic, architectural, and aesthetic cosmology. I want to be crystal clear on this. We are not talking about a proven medical tool or some new law of physics. We are talking about using ancient mathematical proportions to visually and structurally organize urban blueprints. It's a way to give our future cities a deeply resonant mathematical soul.
And this brilliantly illustrates that concept. Imagine a 3D stellated dodecahedron, a shape often discussed by researchers. It is a stunning piece of mathematical fractal geometry. Imagine this kind of perfect symmetry acting as the visual scaffolding for our space cities. Instead of random, chaotic urban sprawl, the city's architecture would be elegantly organized around these repeating, harmonious geometric patterns.
These highly realistic geometric nesting models show us exactly how this creates a mathematically precise aesthetic. Think of it as the user interface for the space habitat. By embedding these nested symmetries into the very layout of the streets, the parks, and the bulkheads, the environment feels deeply organic rather than sterile. It provides a naturally comforting visual rhythm to the people living inside.
So, how do architects actually use this? Well, they follow an aesthetic blueprint. First, they might implement mathematical sequences using what's called the 7-engine loop to dictate how neighborhoods and structures gracefully branch out. Second, by collapsing digital roots, they can create a repeating 6-beat architectural pulse that becomes a true rhythmic musicality to the layout of the city. Finally, they conceptually synchronize this structural design to echo comforting planetary resonances like Earth's 7.83 Hz Schumann resonance. It's all about generating a beautiful cityscape that feels like an extension of nature itself.
When you combine the massive structural engineering of the O'Neill cylinder with a deeply intentional aesthetic cosmology, you get more than just a space station. Which brings us to part 5, a blueprint for tomorrow. You get a fundamentally new way of living.
In a closed-loop environment, society itself has to be as meticulously designed as the hull of the ship. Models like the proposed Etherbios ecosystem suggest that an off-world colony requires radical social software. Because in an environment with literally zero margin for error, every single person is a vital resource. In this model, involuntary unemployment drops to zero. Traditional taxes are completely abolished, replaced by a system where 9% of company profits are distributed directly back to workers. And to maintain absolute economic stability in such a fragile setting, they propose avoiding traditional money entirely in favor of a simulated currency specifically designed to prevent inflation. It's a bold attempt to create a highly efficient, equitable system where no human talent is wasted.
Which leaves us with this final, truly provocative question. Are we ready to build our resonant vessel? Because surviving the stars is going to require way more than just brilliant structural engineering and thousands of tons of regolith. It demands an architectural and social cosmology that actually makes the journey worthwhile. We have the blueprints for the hardware, and we are dreaming up the software. The only question is when we decide to start building. Thank you so much for joining me on this explainer, and keep questioning the patterns around you.